Okay, here's the next example. Sorry, this should be example 2. Okay, so in this example here, I'm going to read it and then I'll solve it. It says a lighthouse is 200 yards from a bike path along the edge of a lake. Okay, so the lighthouse is 200 yards from a bike path. Okay. So a lighthouse is 200 yards from a bike path along the edge of a lake. A walkway to the lighthouse is 400 yards long. Find the acute angle theta between the bike path and the walkway. Okay, so we've got a lighthouse, so let's draw this out. See if we can draw an accurate picture. So here's the lighthouse, right? And then we've got this path, right? And the path a walkway to the lighthouse is 400 yards. 400 yards long, right? So this distance here, 400 yards, right? Okay, now, it says there's a bike path along the edge of the lake that's 200 yards from the lighthouse. Right? So let's do it this way. Let's draw the lake. So we've got this lake, right? Let's do it a little different. Okay. Okay, let's say we've got this bike path. And let's say here, right? And so we've got this distance here. And then there's a path, or the bike path is 200 yards from the lighthouse. And then a walkway to the lighthouse is 400 yards long. Actually, let's do it this way. Okay. Because of the lake, we're going to assume that this is pretty straight here, because we're talking about the edge of a lake, a bike path, right? So we know the path, the distance from the lighthouse to the bike path is 200. Okay, so let this represent the bike path. So this will be 200. And then the path that goes basically from the bike path to the lighthouse, the walkway, is 400. Yards. Okay? So again, we have a right triangle, and the question is find the acute angle between the bike path and the walkway. So the bike path is here, this is the walkway, so this is going to be our theta. Okay, so now that we've got it set up, let's solve it. Okay, now since this is the angle, what's the relationship of the two sides? It's the opposite and the hypotenuse, right? So which trigonometric function are we going to use here to solve for the angle in this case? Well, it's going to be sine, right? So sine theta equals opposite over hypotenuse. Okay, so that's what we're going to use in this case. Okay, now all we're going to do is now plug in the values, because the opposite is 200 yards over 400 yards, which is going to give us 0.5, right, or a half, right? So now all we have to do is ask yourself, it's an acute angle, right? So what angle, right? Because we want to find the angle. So we have to ask ourselves, the sine of what angle will give us 0.5? Okay? Think about that. Okay, so you should recognize from the unit circle, right, that the sine of what angle will give us a half. So remember, sine is y, right? So which angle gives us a y value that's 1/2? Okay, that's going to be a 30-degree angle, or pi over 6. Okay, so in this case here, theta equals 30 degrees. Okay? Now, what if theta is not a special angle? Well, in that case, you can estimate its value. Okay? For example, we have the acute angle. And for example, if the, just for an example, what if it was 0.6, right? What if it was 0.6? Then what we could do is we could reason that we know that sine of 30 degrees is a half, right? Because we know the special angles from the unit circle, right? And the sine of 45 degrees is 1 over square root of 2, right? We could approximate that to 0.7071. And so we can reason that the angle is somewhere between 30 degrees and 45 degrees. Okay? Now, in later videos, we're going to actually dive into how we can exactly find those angles where it's not one of those special angles that we know from the unit circle. So just stay tuned. We'll get to that. Okay. Other than that, that's the answer. And I'll see you next time. Have a great day.